All right, we're going to talk about special equations today. So before we can answer the essential question, how do I solve special equations? Let's take a second to talk about what special equations actually are. So what is a special equation? It's an equation that does not have exactly one answer. Normally equations will have exactly one answer, like x equals 2 or y equals 5. But a special equation won't have exactly one answer. Let's take a look at what that means. If you need more time, press pause to finish writing down your notes, and then press play when you're ready to continue. So if we take a look at these two examples, example A, we have x plus 4 minus 6x equals 6 minus 5x minus 2. And example B, you can see that. I'm not going to read that out loud. The first thing we want to do in any case is we want to go ahead and combine like terms. On the left-hand side of example A, we see that we have two different terms with an x, variable terms. On the right-hand side, we see that we have two different terms without a variable. Those are our constant terms. For example B, we see a very similar setup. On the left-hand side, we have two variable terms that we can combine. On the right-hand side, we don't see any like terms that we can combine. So our first step is going to be to go ahead and combine like terms. And the color coding there just shows which terms will be combined. So in example A, 1x minus 6x is negative 5x. So we get 4 minus 5x left over. 6 take away 2 is 4, so we get 4 minus 5x on the right side. So really look at that equation and what it's saying. 4 minus 5x is equal to 4 minus 5x. Seems pretty clear. They should be equal because they're exactly the same. In example B, when we combine our like terms, negative 8x plus 9x would be positive 1x, since negative 8 plus 9 is 1. So we have x plus 6 equals negative 17 plus x. Obviously, those look very different. They don't look exactly the same like example A. In either case, our next step would be to try to move the variables to the same side, just like we did last week with two-sided equations. If I wanted to move the minus 5x to the other side, so move the variables to the left, I would undo subtraction by adding. That would give me the canceling out or zeroing out effect that I would want here. But what happens on this side is we get the same thing. Negative 5x plus 5x is also 0. And what we're left over with is just the two numbers. 4 equals 4. On the right-hand side, on example B, we move the variables to the same side again. So if I want to do undo addition, I undo addition by subtracting. X minus x is 0, canceling those out. And x minus x is 0, canceling those out. So in both examples, A and B, the variables canceled out on both sides. Normally we don't see this. Normally they cancel out on one side and you combine them on the other side to become something else. So when this happens, this results in a special equation. In example A, we got a statement like 4 equals 4. There's a check mark there because that's true. 4 equals 4. In example B, the leftover numbers were not equal. They were not the same. So there's a little X there to show that that's not true. So here's how we answer something like this. If the equation is true, like 4 equals 4, we would write all real numbers as the solution. So our answer in this case wouldn't be something like x equals 4 or x equals 0. It's just simply all real numbers as the final answer. In example B, when we have a statement that's not equal, two numbers that are different, meaning it's false, we would write no solution. Okay, so that's the terminology that we would use to answer it. But what does that really mean? All real numbers means that every real number would be a solution. Any real number. So that means any natural number, any whole number, any integer, any rational number, even any irrational number, like the square root of 2 or pi. So any number that you plugged in for x on the left-hand side of this equation, and also in the same equation for x on the right-hand side, the left-hand side's value would be the exact same as the right-hand side's value. That's what makes the equation true. So basically, any number that you plug in and check the answer will give you a true statement. In example B, however, we're saying there aren't any solutions. There are no solutions possible. So we could take numbers and guess and check for the rest of our lives. We could spend 80 years on this. Not me, I can't, I'm too old, but you guys hopefully will live another 80 years. You could pick any number you wanted, guess and check for the rest of your life, and you will never get the left side to equal the right side. It will never work because it's not possible. It's kind of like a trick problem. So let's take a moment to try practicing a little bit of solving like a multi-step equation, but also incorporating this idea of a special equation. Okay, so what I'd like you to do is I'd like you to go ahead and pause the video and try this on your own. See how far you get. All right, so let's check and see how you did. The first thing I would do on a problem like this is go ahead and distribute on both the left-hand side and the right-hand side of that equal sign. So on the left-hand side, we're distributing the 3 by multiplying it into the parentheses. So 3 times 4x would give you 12x. And 3 times negative 6 would give you negative 18. So that's the left-hand side of the equal sign. On the right-hand side, we would also distribute. But this time we're distributing the 2. 2 times 6x is 12x. And 2 times 9 is 18. So if we take a look at what we have there, 12x minus 18 equals 12x plus 18, we notice they're different. Our next step in the two-sided equation is to try to move the variables to the same side. Just to be consistent, I'm going to go ahead and try to move this 12x to the left. Because that 12x is a positive value, to move it, I'm going to subtract 12x, just like we did last week. I have to, excuse me, make sure that I do the same thing to both sides. So I subtracted 12x on the left and the right. And when I simplify, I see that 12x minus 12x is 0, like I wanted it to do, this cross out. But then I also see on the left-hand side here that 12x minus 12x is 0 again. So I get 0 minus 18, which is negative 18, equals 0 plus 18, which is positive 18. So the variables canceled on both sides. That tells us right away x is gone. This is a special equation. And we ended up with two numbers that are not the same. Because if we ask ourselves, is this true? Is negative 18 equal to positive 18? No, they're nowhere near the same. If I owe you $18, that's not the same thing as somebody owing me $18. It's completely different. So what do we write when the two numbers are not the same? Let's look back at our examples. Was it like example A or example B? Well, in example A, we got two numbers that were the same. In example B, we got two numbers that were different. So our example here is like example B. We want to write no solution. So our answer here isn't x equals 18. Certainly isn't x equals negative 18. Our answer is no solution. Let's try one more. Again, I'd like you to copy this down and try it on your own. And I'd like you to pause the video. And when you're ready to resume, you can press play and see how you did. All right, let's check and see how we did. The first thing I would do here is, starting on the left-hand side of the equation, I want to simplify what we have there. So we're going to start by distributing the 2 by multiplying it into the parentheses. 2 times 4x is 8x, and 2 times 9 is positive 18. I get 8x plus 18. On the right-hand side of the equation, there are no parentheses, so I do not have to distribute. But I do notice that I have 2 variable terms. I have a 6x, and I have another positive 2x. If I add those together, 6x plus 2x, I'll get 8x. And then I bring down the plus 18. As we look at this equation, we notice something right away. 8x equals 18 equals 8x plus 18. Excuse me. 8x plus 18 equals 8x plus 18. Let's continue and see what happens. We have variables on both sides of the equation, so the next thing we want to do is to try to move these variables so that they're on the same side. So in either case, I'm going to need to subtract 8x to undo the positive 8x, to basically turn it into 0. But I have to do the same thing to both sides of the equation to keep it balanced. So I subtract 8x on the left and the right. And if I simplify what's left, 8x minus 8x is 0, and 0 plus 18 is 18. On the right-hand side, 8x minus 8x is 0, and 0 plus 18 is 18. My variable terms canceled out on both sides of the equation again. I don't even have x as part of my equation anymore. All I have left is 2 numbers, 18 equals 18. So I notice that this is a special equation. So I have to think about, what does it mean if I get 2 numbers that are actually equal to each other like this? 18 equals 18, that is a true statement. So if I look back at my notes, when it's true, we should write all real numbers to indicate that x could actually be anything. Any number you could come up with would actually be a solution. But we have to show it's not just that one number that you come up with, it's all possible real numbers. It's an infinite number of solutions. So there's our 2 cases for special equations. Now it is still possible to get one answer, like x equals 5 or x equals -2. So watch out for that on the assignment today. It doesn't mean that you're always going to get a special equation. You probably will get more today, but maybe not all of them. All right, first main idea is literal equation. So what is it? It's an equation with 2 or more variables. Typically, we've been dealing with only one variable lately when we solve one-step, two-step, multi-step equations, even two-sided equations. If it has x on the left and x on the right, that's still just one variable. So we're talking about 2 or more different variables. So examples might be formulas, are different types of literal equations, like y equals mx plus b, a popular formula used back in 8th grade Algebra 1 for the slope-intercept form. Or even a equals L times w. That represents the area of a rectangle, length times width. In each case, there are equations that have 2 or more different variable types. So how do I solve literal equations? The first thing you want to do is identify which variable you are solving for. Then you want to identify the operations and the order in which they were applied. We work backwards to get the variable by itself. Let's take a look at some examples. Example number 1 says m minus n equals 5. Well, normally we just solve for whichever variable's there, but there's 2 variables. So we have to look in the instructions. It says solve for m. So our job is to try to get m by itself. So what we have to do is look at what else in the equation do we have to move to the other side to get n by itself. Excuse me, m by itself. And in this case, we have to move the letter n to the other side. So we have to think about how is the n attached to the m? Well, the n was being subtracted from m. So if we want to undo the minus n, we want to use addition. We add n to both sides. And you might be thinking, well, how do I add n to 5? And it's a good question. And we do, but we don't really combine them because they're not like terms. What we're left with here is that negative n plus n is 0, just as we've been seeing when we move things, it cancels out over there. And we're left with m equals 5 plus n. Remember, I can't add those two things together. It does not become 5n because that would be 5 times n, and that's certainly different than addition. So in this case, that's our answer. We got n by itself. Excuse me, m by itself. M equals 5 plus n. Number 2, we have c minus 2d equals 5. Again, there's two different variables. We have to check the directions to see which variable are we supposed to get by itself. And it says here to solve for d. So if we're going to get d by itself, we're going to have to get rid of the variable c, and we're also going to have to get rid of that 2. So if we think of what's applied and how were those operations applied to the letter d, d was multiplied by 2, or technically negative 2, and then c was added to that, c minus 2 times d. So we're going to work backwards. We're going to start by moving the c to the other side. I draw my train tracks, and because c is positive, I can move it to the other side by taking it away. Let's see what we're left with. C, take away c, is 0. And when I bring down the 2d, I have to be careful to remember it's actually negative 2d. On the right-hand side, I have 5 minus c, which I cannot combine those because they're not like terms. I have to leave it as just 5 minus c. So we're getting closer. Remember, our goal here is to get the letter d by itself. So think about, how do you get rid of the negative 2 in this case? Well, it's currently negative 2 multiplied by d. So if we want to undo the multiplication, we would use division. Divide both sides by negative 2 gives us d equals 5 minus c all over negative 2. Now there is a way of simplifying that, but for today, I'm okay with that. The key today is to get the indicated variable by itself. Let's look at number 3. It says to solve for a, which means we're trying to get a by itself. So we're going to have to get rid of the 2 that was multiplied by a, and we're going to have to get rid of the 3b. Okay, think of that as one term, the 3b. We can move that all in one step. We're going to start by undoing the addition. We undo addition by subtracting. So that's going to reverse the impact of adding 3b if I subtract 3b from both sides. Since 3b minus 3b is 0, that leaves us with 2 times a equals y minus 3b. To continue getting a by itself, we need to undo the multiplication. So I divide both sides by 2. And I'm left with a equals y minus 3b all over 2. We solve for a because a is by itself. Here's number 4. Solve for m. This is a popular formula for the slope-intercept form of a linear equation, y equals mx plus b. This time, the variable I'm trying to get by itself is on the right-hand side of the equation. So I want to move everything else to the left-hand side. M times x plus b. If I work backwards, that means I want to undo the plus b first. So I subtract b from each side, and what I'm left with is y take away b equals mx, since b minus b is 0. You have to keep in mind what you're trying to get by itself. We're trying to get the m by itself. So on the right-hand side, we have to get rid of the x. To undo multiplication, we divide. Divide on both sides to keep it balanced. X divided by x is just 1, essentially canceling out since m times 1 is m. And on the left-hand side, we just bring it down. Y minus b all over x.